This is an overview of the SeeDB tool. So in the Mimic use case, after getting an overview of the dataset through the Explorer interface, which shows what data types are in the dataset, what is the distribution of values, and so on, suppose that the user would like to answer a specific question about the dataset. And suppose that this particular question is how male and female adult patients differ in their ICU stays. For example, the user may wonder if the typical ICU stays are longer for males versus females. Another question that the user might want to answer is whether males are admitted to the ICU predominantly for certain conditions compared to females, and so on. To answer these questions, the user can use the tool SeeDB. We have built SeeDB to be a visualization recommender. What this means is that given the dataset and a task of interest, SeeDB can automatically identify and visualize interesting and relevant trends in the data. The SeeDB interface is shown here. We adopt a mix of automation and interaction to support data analysis. What this means is that SeeDB can let you visualize certain data sets manually. For example, this means that SeeDB allows you to visualize data sets manually or obtain recommendations through our system. So suppose we're looking at the ICU stays dataset to examine the differences between male and female patients. So suppose that you want to plot ICU stays by gender and you're interested in examining how long the patient stays in the ICU. So you can ask the system to plot simple bar plots, scatter plots, trend lines, and so on. So this shows an example of a visualization that might be generated. We can also plot we can also graph plots that show the differences between two data sets. For example, suppose we are looking at male patients versus female patients. So gender equals male, gender equals female. Additionally, let's also say that we want to limit our exploration to adult patients. So let's add the two filters in. We have ICU age group equals adult in both. So as before, you can choose to plot each of these, or you can choose to ask SeeDB for recommendations. What this does is it looks at the data set that are identified by the two filters, which is the male adult patients and the female adult patients, and it finds visualizations that show differences in the two data sets. So we show a whole bunch of visualizations at the bottom. The user has the choice to look at thumbnails, examine them. The user can also zoom into any visualization that he or she finds interesting. So this one looks kind of interesting. It shows the average length of an ICU stay on the y-axis and what the last unit of the ICU was where the patient was admitted. So this shows that if the patients were in the CSRU, which is the cardiac surgery recovery unit, then their average length of stay is 8,000 for males and about 9,000 for females. What is interesting about this chart is that it shows that when a patient is admitted to the FICU last, then the length of stay for male patients is much longer, twice as much in fact, than the length of stay for female patients. This indicates a trend that might be worth further exploring and seeing if there is something to be followed up on there. So let's do that by simply adding a filter. We would like to examine the ICU last service, which is equal to FICU, which is just a particular ICU building. And we want to set that filter for both males as well as females. So we do that here. And once again, we ask it for recommendations. As before, it populates new recommendations here. You can browse them. You can examine the thumbnails and so on. So the one that I find really interesting is this one. This shows that Of all the other units, it seems like patients, male patients in particular, who go to the CSRU have very long ICU stays. They're in fact about 20 times longer than the stays for female patients in the CSRU. This is interesting. We also observed that for the FICU unit, the length of stays are actually pretty similar. So that makes you wonder if it is the patients whose first visit was to the CSRU and the last service was FICU are in fact skewing the whole data for male patients who were admitted to the hospital. So you might have several questions about the details of this data. This is where you can use the manual visualization building component and build some plots which show other views of the data. So here we're examining how many patients were admitted to the FICU and CSRU respectively. We find that although a lot of patients were admitted to the FICU, CSRU had very few patients. It had 5 male patients and only 1 female patient. This indicates that we are possibly seeing what is an outlier in this data set. And maybe these male patients who first get admitted to the CSRU and then their last service is the FICU, maybe deserve some more attention to understand why their hospital stays are longer, and perhaps there's something that can be done to reduce those days. We have this great ability to bookmark any visualizations that are interesting so that you can come back and look at these visualizations later. So once we've identified some trends or patterns that are worth exploring, we can use tools that can perform sophisticated statistics with machine learning in order to understand the data further.